Hello students, this is lesson U2A02a. Hopefully by the end of the lesson you should be able to say I can perform translations and glide reflections on a coordinate grid. So let's take a look. Alright, so a couple of things here, and I want you to copy this information down on a sheet of graph paper, preferably, and there's something here that I want to talk about. So pause the video and copy this down. The thing I want you to focus here is this notation, this guy right here. And I'm going to get back to this. All right. Is this thing right here. So the T here, okay, stands for translations. So as we had studied in the previous video, that a translation means to move things around either horizontally or vertically or a combination of both, okay? And there's a notation here. This thing right here, okay, in mathematics we refer to it as a vector, okay? And what a vector is, it's basically something that has direction, okay? So this is saying translate something. What is that something? That's triangle ABC. It's saying to translate this, okay, this said triangle, 4 units to the right and 3 units down. Okay? So how are we going to do that? Well, we're going to take every single point and we're going to move it 4 units to the right and 3 units down to get A prime, B prime, and C prime. And here are the coordinates after the transformation. Let's take a look at the next example. Or actually, before we take the next example, it is actually important for us to talk about what's happening algebraically here. So this is the algebraic understanding and interpretation, okay? So this is the vector to which we are moving said object, and the object here is a coordinate. So what's really happening is we're taking all the x coordinates and we're adding the x direction to which we're moving something, and then we're taking a y coordinate and we're adding the y coordinate to which we're moving something. So as a result, the transformation of coordinate AB will become A plus C and B plus D. All right, so what we have here is another notation, and this right here, the symbol, okay, means we're taking a composition. What exactly is a composition of transformation? It is, we are taking multiple transformations and putting them together, okay? So what we're doing is we're taking this point and then we're performing a reflection. The capital R here stands for reflection. We're reflecting it over the axis y equal to 0. And then finally, we are performing a translation. An alternative way of reading this is using set of parentheses. Oh, and by the way, that was not by accident, or that was not by mistake. The way in which we read a composition or transformation is we are reading from left to right. First we're reflecting, and then we're translating. Okay, so this means we are reflecting first, and then we're translating. We're always reading things from right to left. What am I saying? We're always reading things from right to left, not left to right. An alternative way of reading this, okay, is using a set of parentheses. Preferably, actually, my personal preference is using sets of parentheses like this, as it organizes, our train of thought a little better. If you look at this, okay, this is saying we're reflecting that point first, and then after we perform the reflection, then we're performing a translation. This makes more sense. Again, we are we're moving from right to left, just like we're doing over here. It's just that with this notation, it just makes a little more sense why we're reading from right to left. So what would happen if we have 3 different transformations at play? Well, no different, okay? We are going to perform all the transformations moving from right to left. So first there being a translation, and then a reflection, followed by another translation. And then alternatively, okay, this is the other way of writing the composition of transformations. We are going to be performing, it's kind of like PEMDAS if you think about it, right? We're starting from the inner parentheses here first. So we'll start with this, translation, then a reflection, and then lastly, another translation. So again, in summary, I'm reiterating myself here. When you're reading this, you're always reading things from right to left. All right, so let's actually do an example together, okay? So you have triangle ABC that's graphed. Pause the video for a moment, see if you can find the coordinates for triangle ABC after this composition of translation and reflection. So hopefully after some time now you had an opportunity to figure this out. First, we're going to perform a translation. So we're translating, we're moving points A, B, C to A prime, B prime, C prime. And then afterwards, we are taking that triangle and we are reflecting it over the axis x equal to -1, which happens to be a vertical line. So when we reflect it, we'll end back in the fourth quadrant there. And the coordinates for A double prime, B double prime is given by these coordinates here. Let's take a look at the next example. All right, so actually, this is not an example. This is a recap. So this transformation that we had just undertaken is called a glide reflection. This is going to go into your added repertoire of vocabulary as well as skills. Whenever you're performing a combination of either translation and reflection or reflection and translation, it has to have both of those two things in there, okay? It is referred to as a glide reflection because what you're doing is you're not only reflecting, but you are moving the object either horizontally or vertically. So that's why it appears to be a gliding. There's the gliding motion here, right? So you're gliding and then you're reflecting. All right, so we're going to perform another glide reflection, okay, with this quadrilateral. Pause the video for a moment to see if you can figure out where quadrilateral ABCD will end up. So after some time now, we are performing a reflection first. So we're reflecting over y equal to -1, which means it's going to reflect over that horizontal line. And A prime, B prime, C prime, D prime will all end up in the fourth quadrant. And then afterwards, we're going to perform a translation, which means we're going to, in this case, we are going to move 8 units to the left and 6 units up. And we're going to end up there. And these are our coordinates for A double prime, B double prime, C double prime, and D double prime. Let's take a look at this next question here, which is a little more higher level thinking. Okay, so say for instance, okay, we're performing 2 translations. Again, we're translating 3 to the right, 7 units up, and then 4 units to the right and 5 units down. What will happen? What could be said about the overall translation then? How will that overall translation work? So pause the videos to see if you can figure this out on your own, and then we will reveal. So hopefully you had some time to think about this. So let's take a look. Well, let's say we start off at some random starting point, right? And it doesn't matter where you are, but the point is we're moving 3 units to the right and then 7 units up. And then from there, we are going to move 4 units to the right and then 5 units down. So if you look at this, okay, we are traveling from the start to finish, which is right there. So what is that? How many units to the right and how many units up are we going? Well, as it turns out, we are just adding all the horizontal and vertical motion here. We're moving 3 plus 4 units to the right, 7 plus minus 5 units, right? So really at the end, it's 7, 2. We are moving 7 units to the right and 2 units up. Moving on. So what about this? If I perform a reflection, okay, of this coordinate over the y-axis, I'm sorry, not over the y-axis, but over y equal to -1, and then we perform another reflection over x equals to 3, that would be equivalent to translation of how many units to the right and how many units, how many units horizontally and how many units vertically. Pause the video to see if you can figure this out. So hopefully you had some time to think about this. Let's take a look. So again, it doesn't matter where we are. Well, actually, no, it does matter because this for this particular example, I told you where we started, which is 2 comma 1. So if we take 2 comma 1, right, and we reflect it over y equals to -1, we'll end up at that coordinate there, which is 2 comma -3. And then we're going to, again, reflect over x equal to 3. We'll end up there. So if you look at this, okay, what is this really? It's a translation of 2, -4. We're translating 2 to the right and 4 down. And that's pretty much it. See you on the next video.